Hi, this is Dr. Redkay, and we are going to review validity threats for 710 research methods. Can you see, you can see the threats to internal and external validity? You can see the module? Okay. All right. So there are really 4 textbooks that guide this section, this module. And you didn't have to buy any of those. I've sort of copied the chapters that I thought were the most critical and most important. And so that's kind of how this section is divided. So the first one here is Morling. It's actually a psychology textbook, which I think is wonderful. And the 3 things that we get from Morling are what's called the 3 claims. And she describes basically the different types of research that are out there. So quantitative research. So the first one is frequency. So some percent of people do Y or RY. So it's observational studies. So 3% of the American population are, whatever, sexual offenders, something along those lines. Okay. Association. X is associated with Y. LGBT people are significantly more likely to be depressed and anxious. Okay. It is blank associated with blank. It is not causal. It is simply associated. So the example here is when ice cream sales increase, drownings increase. That does not mean that ice cream causes drowning. The factor is actually just warmer weather causes more people to swim, which causes more people to drown. So this is what is most often referred to as correlation, not causation. So the causal claim is causation. That's when we can say blank changes blank, X changes Y, CBT significantly reduces depression. Okay, those are the 3 claims. And then this really goes into helping students understand the difference between, again, evidence, research, or their beliefs, their opinions, right? And they talk about the difference between conspiracy theories and scientific reasoning. One of the powers behind a conspiracy theory is that it's not falsifiable. You can't prove it's not true. So if I, believe that if I put a tinfoil hat on my head and I hide in the basement, aliens can't read my mind, and that's my belief, you can't tell me anything to change that. If you prove to me conclusively it's not true, I'm going to say, no, the aliens have already gotten to you. That's why you think this, right? So that is the idea of falsifiability. You have to be able to falsify something, meaning prove that it's not true. Okay, prove that it's not accurate. Also, just the idea of like accepting research as evidence. Then of course, there's this thing called confirmation bias. I didn't use this term, but I've talked to some of you about it with your research studies. Like if you want to be the researcher, it's not a good idea for you also to be the person who leads the intervention because you want your intervention to work. So as you're assessing it, you have a confirmation bias, like I think it's going to work, so therefore I see it working, right? The other thing too is to think about this idea that research results are what's called probabilistic. It's about probability. So something you should know, particularly for quantitative research, is that typically statistics are involved. And then how do you know if it was effective or not? How do I know that CBT significantly reduced depression? The word significant is really only used when you've done math, when you've done statistics. So it is mathematically significant. That's what it means. And what does that mean, mathematically significant? What it means is that you have this p-value, which stands for the probability that the results are accurate. The threshold for p-value is 0.05. Think of it like a nickel. So if the p-value is 0.05, what that means is that the researchers think that there is a 5% chance that a mistake could have happened. in the research and the results are not accurate, that there was a mistake made somewhere. And the flip side is we are 95% confident that it is accurate. Okay. If the p-value is 0.01, then we are 99% confident that it's correct. And 1%, there's a 1% chance that it's incorrect. Does anybody have any questions on the p-value? Okay, so the example is if Consumer Reports indicates that a Toyota Camry hybrid is a great car and it has very little issues, you happen to buy the car and it has way more issues than what Consumer Reports predicted. So then the question is Consumer Reports wrong? Is Consumer Reports bad or unreliable because you bought the car? And the answer is no, it's not bad because it's based on probability, right? That Consumer Reports, like I said, like p-values, is they are 95% confident that Toyota Camrys are a great car, or they could say 99% of Toyota Camrys are a great car free of most major issues, right? Just because you pick out one that has a problem, it doesn't mean that Toyota Camrys in general are bad, and it doesn't mean that Consumer Reports is bad. That is what we call an anomaly. In research, you will hear people often say, that's not evidence, that's just an anomaly. It's a one-time thing that might have happened to you or to someone you know. A popular example of this is, I don't know if you remember when the COVID vaccine came out, there was some famous rapper, I can't remember who it was. Was it Nicki Minaj? And it was like her cousin or something that she claimed her cousin, it was something to do with his private parts. Like he took the COVID vaccine and he reported something happened. And then she was like, I'm not going to take this because look at this side effect. But none of it ended up being true. But even if it was true, it would be an anomaly. It only happened to one person. Okay, so when we think about research, we prove nothing and everything is probabilistic. Okay, so it is more likely to be true. Okay, so now it's the 4 validities. Okay, so there's internal validity, which means inside the research study. Were the methods good? Were the methods good? Then there's external validity. What that means is, can we say that these results apply to other people, right? I'll give you an example. So CBT therapy is effective with white folks. It is less effective with Latinos. So if I do a study with white folks to say CBT was effective with these white folks, it is not generalizable to other races because I only studied white folks. Okay, if I study Latinos and I find that CBT is not effective with Latinos, that doesn't necessarily apply to other races. It only applies to the people in that study. Now, if we did a better study where we randomized participants, which is very difficult in our field, if we did that, then we could say this does apply to other people. That's external validity. Then we have statistical validity. We could do the statistics and the math and we get a great p-value, but it has a low effect size, which means, yes, it is significant, but is it big enough? So with significant, sometimes you can fake significance. If you have a large enough population, like if you have 30,000 people in your database, it could be significant just because you have so many people, but it doesn't mean it actually had a real impact. And that's where you get into things like effect size or power, correlation coefficient. There's a bunch of other sort of statistical things that you look at to determine how it increases the credibility of the research. Okay, then we have construct validity. That is your measurement tool. Again, all of this is quantitative. So is your measurement tool validated or not? And that's not a feeling, because I'll ask people, is your measurement tool validated? I feel like it is. No, it's not. There, it is or it isn't. There's a research study where they did very complicated math and validated it. Now, when we say it's validated, that means you can use it with different populations, okay? I'll give you an example. I had a legal case recently. I'm arguing with a psychiatrist so they had a child take the PHQ-9. Does anybody know anything about the PHQ-9? Who's that validated for?
Adults.
Adults, not for children, but they gave it to a child. There are 3 questions that are different, which can swing the results by 9 points, which could result in the person being severely depressed or only moderately depressed. That makes a difference. The kid went on and died by suicide. It makes a difference. So if a measurement tool is validated for adults, you give it to adults. If it's validated for children, you give it to children, right? You only use it for the population that it's validated for. Some tools are wonderful, like the PHQ-9 is wonderful. You can give it to any adult, any race, because it hasn't been shown to not be effective with certain races. You could, if you did more studies, you might find that it's not effective, but so far the research shows that it is, that it's appropriate. Okay, so those are the 4 validities, and you should know a little bit more about those validities. You need 3 things to determine a causal relationship. You need 3 things in a research study to determine if one thing impacted the other. 1, they have to be correlated, right? So when CBT happens, depression goes down. So sometimes correlation can, it's either an inverse relationship or a same directional relationship. CBT goes up, happiness goes up, right? CBT goes up, sadness or depression goes down, right? So that is correlated. When one thing happens, another thing changes. Temporal precedence. This is number 2. Temporal precedence mean one thing has to happen before the other. Okay, so you measure depression, they're depressed, then you give them CBT, then depression changes. So the CBT had to come before the depression change. That makes sense. Temporal precedence. The CBT, the intervention, the thing that fixes the other thing came before the thing that's fixed. The last thing is internal validity, right? It had to be a good study. You have to have a good study. Okay, so all of that came from the Morling textbook. That's textbook 1. We have 3 more to go. Okay.